Antarctica isn't just ice. It's a time machine full of surprises. For millennia, this vast white continent at the bottom of our world has been shrouded in mystery, a place seemingly hostile to all but the hardiest of life. It's a landscape of brutal winds and unimaginable cold, a desert of ice stretching further than the eye can see. Yet, beneath this frozen veneer, hidden from sight for millions of years, lie secrets that have patiently waited for us to find them. Secrets that challenge our very understanding of the world we thought we knew. This is a story of human curiosity and resilience, of scientists venturing into one of the most extreme environments on Earth. Imagine a body of water, larger than some of the Great Lakes of North America, buried beneath 4 kilometers of solid ice. For millions of years, it has been utterly isolated from the world above, a pristine, dark, and silent realm. This is Lake Vostok, the largest of Antarctica's subglacial lakes. Its existence was first hinted at in the 1950s by Russian seismic soundings. But it wasn't until the 1990s, with advanced radar technology, that its true staggering scale was revealed. A liquid world, sealed in a frozen vault. The prospect of reaching this hidden lake became one of the greatest scientific endeavors of our time. It presented an immense challenge. How does one drill through 4,000 meters of ancient ice without contaminating the untouched environment below? It was a painstaking process, taking decades. Russian scientists at Vostok Station slowly, carefully advanced their drill, stopping just short of the water's surface to avoid introducing modern microbes into this ancient system. The final breakthrough was a moment of extraordinary tension and anticipation. Because Lake Vostok is not merely a geographical curiosity, it is a potential biological time capsule. The Antarctic ice sheet does more than just preserve. It also conceals. Beneath its immense weight lie the very bones of the continent, a landscape of mountains and valleys unseen by human eyes. And in a region known as Wilkes Land, satellites measuring Earth's gravity field detected something strange. A massive anomaly, a concentration of dense mass buried deep beneath the ice. Subsequent surveys painted an even clearer picture. The faint outline of a colossal circular rim, over 500 kilometers in diameter. This was the unmistakable signature of a gargantuan impact crater, more than twice the size of the Chicxulub crater, linked to the extinction of the dinosaurs. Dating such a buried feature is incredibly difficult, but geological clues suggest the impact occurred around 250 million years ago. This timing is profoundly significant. It coincides perfectly with the Permian-Triassic extinction event, the most devastating mass extinction in Earth's history. The Great Dying. This event wiped out over 90% of marine species and 70% of terrestrial life. For decades, massive volcanism was the leading theory. The Wilkes Land crater introduces a dramatic new suspect. Could a colossal asteroid or comet have struck Gondwana, triggering this unparalleled biological crisis? The impact would have vaporized rock, sent shockwaves around the planet, and likely triggered the very volcanic activity already implicated. A 1-2 punch to life on Earth. Confirming this will require drilling through kilometers of ice to reach the crater, a monumental undertaking. But the evidence forces us to reconsider Earth's history, a cosmic shooting gallery. Antarctica is, in many ways, an alien world on our own planet, and a repository for pieces of other worlds. The vast white expanse is perfect for spotting meteorites that fall everywhere, but are preserved and concentrated here. Ice flow acts like a conveyor belt, gathering these cosmic travelers and depositing them against mountain ranges, the greatest meteorite hunting ground on Earth. In 1984, a routine expedition in the Allen Hills region found something extraordinary, a small rock, under 2 kilograms, identified as a piece of Mars. It was designated Allen Hills 84001. Trapped gas bubbles matched the Martian atmosphere measured by the Viking landers, a chemical fingerprint from the red planet. Blasted off Mars, It drifted through space for millions of years before landing on Antarctic ice. In 1996, NASA scientists reported features interpreted as possible fossilized microbes. Tiny, segmented shapes, minerals, and complex organics. The debate exploded. Non-biological explanations addressed many claims, yet the possibility was never fully dismissed. Regardless, ALH 84001 and its kin revolutionized planetary science. Tangible Mars samples for geology, climate, and history. They helped spur a renaissance in Mars exploration. Rovers and orbiters searching for answers first posed by a small rock on the ice. Antarctica, the frozen desert, became our gateway to the red planet. Ice seems solid and inert, but in Antarctica, it is a living library. Each year, new snow buries the old, compressing into glacial ice. Tiny bubbles trap the atmosphere, pristine samples of ancient air, frozen in time. Epica drilled more than 3 kilometers at Dome Sea, one of the coldest, most remote places on Earth. Each ice core is a timeline of climate history. The deeper, the older. The result, the longest, most detailed climate record ever. 800,000 years. Ice chemistry reconstructs temperatures. Extracted air reveals greenhouse gases like carbon dioxide and methane. Measured at the moment the snow fell. What emerged was revolutionary. Earth's natural rhythm of ice ages and warmer interglacials, repeating roughly every 100,000 years. Most stunning, temperature and CO2 moved in near-perfect tandem across 800,000 years. High CO2, warm planet. Low CO2, ice ages. Direct physical evidence of greenhouse influence. For 800,000 years, CO2 never exceeded 300 parts per million. Today, it's above 420, a geologic instant spike. The ice doesn't just tell our past, it warns us about our future, transforming our understanding of our impact on the planet. When we picture Antarctica, we see an endless expanse of white, a world of ice. But the continent holds a deep, dark secret, the ghosts of ancient forests. Across the Transantarctic mountains, geologists found petrified wood, fossilized leaves, and thick seams of coal. These are remnants of vast, thriving forests, proof of a greener past. Coal speaks of ancient swamps that once covered the land. These fossils were pivotal for continental drift. Alfred Wegener's bold idea that continents move. Identical Glossopteris fossils in South America, Africa, India, Australia, and Antarctica. Impossible unless the continents were once joined as Gondwana. Antarctica was not always at the pole. It drifted there. Some forests persisted even at high latitude, enduring months of winter darkness, challenging our understanding of plant adaptation. Silent stumps in frozen mountains are storytellers of a different Earth. Proof that today's map is only a moment in time. Dinosaurs evoke jungles and swamps, so finding one in Antarctica seems preposterous. In the summer of 1990-91, David Elliott worked high on Mount Kirkpatrick, 4,000 meters up, 650 kilometers from the South Pole. Weathering out of the frozen rock were bones of a large predatory theropod, over 6 meters long, kin to Tyrannosaurus rex. A delicate bony crest arced across its skull, like a frozen wave. Cryolophosaurus, the frozen crested lizard. It lived about 190 million years ago, when Antarctica was part of Gondwana, already at high latitude. Months of continuous daylight in summer, months of darkness and cold in winter. This fossil showed large, active dinosaurs thrived in polar regions, suggesting warm-blooded traits or adaptations to generate heat. Its anatomy mixed primitive and advanced features, an early offshoot toward giants like Allosaurus and T-Rex. Its presence in Jurassic Antarctica became a key data point for dinosaur dispersal as Gondwana broke apart. A triumph of science in a brutal place. The age of dinosaurs was global, from the tropics to the poles. We once thought Antarctica's ice rested on frozen static ground. Lake Vostok hinted otherwise, but many assumed it an anomaly. With satellites, airborne radar, and gravity measurements, a radically new picture emerged. The world beneath the ice was dynamic and wet. A continent-spanning network appeared. Subglacial lakes, rivers, and streams. Not just one lake, over 400, hidden beneath kilometers of ice. These are not stagnant ponds. Many are interconnected, part of a vast hydrological system, some filling while others drain. Immense subglacial rivers flow for hundreds of kilometers, a plumbing system in total darkness. Liquid water persists under pressure from overlying ice and gentle geothermal heat below. Each lake is a potential oasis, a hidden biosphere separated for millions of years. Water at the base lubricates the ice. Vast river systems mean large areas are sliding over a film of water, speeding ice toward the ocean. Warming climate adds surface melt that trickles down to the bed, making this hidden plumbing critical to sea level forecasts. 7 discoveries. 1 frozen continent that's rewritten science. From a hidden scar of planetary catastrophe to the fossilized ghosts of ancient forests, Antarctica made us reconsider Earth's history. It showed us messengers from Mars, archives of our planet's climate, and a vast, hidden world of water flowing beneath the ice. This is no barren wasteland. It's a dynamic, essential part of Earth's system. Each discovery opens new questions. What else lies buried under kilometers of ice? What forms of life thrive in dark subglacial lakes? The story of Antarctica is far from over. In many ways, we've only read the opening chapter. The greatest discoveries may still lie ahead. If this journey sparked your curiosity, please like and subscribe for more hidden wonders. Tell me which Antarctic mystery to explore next.